Hi everybody, welcome to Creative Coding on the Web. My name is Devin Bailey and the pronouns I use are he, him. I'm going to take a moment to explain a little bit about my background and then maybe do a round of introductions if there aren't too many of us in this workshop. So I'm a member of the Research Technologies and Data Visualization team. I'm a consultant here at the University of Arizona. So I work with researchers, students, and faculty to bring their data to life through drop-ins, one-on-one consultations, and collaborative projects. I also do workshops like this one, and I'm very excited to get started. And so today we are going to be doing art on the web. And I know a lot of the stuff that we're going to cover is all about making fancy pictures with code, but I really can't emphasize enough the benefit of starting with a pen and paper or some way to draw. There are a lot of times in which I get stuck with problems in the code and I don't go back to the pen and paper to make sure that my ideas are working, and I can lose a lot of time that way and get frustrated. But having the pen and paper can help you to make sure your ideas are still flowing, and it can help you, stay on top and stay positive about the art that you're trying to make. So we are going to be using a tool, and you may have heard of it, but it's something called processing. And it's been around for a while. And processing is a great system for artists and people who want to make all kinds of programmable art. The original version of processing was written using the Java programming language, and it normally runs outside of the web browser. And it requires an installation. It's not very tricky, but what we're going to do today is actually, it's based off of processing, and it's called P5, and instead of Java, it is JavaScript. And what's great about it is we don't have to install anything. We can just get started going straight to here. This is just one of the examples of why I like to do web visualization, because you can get up and running right away, test out things, find other people's examples, and use them and modify them with the proper attribution if you get rich and famous. But it's definitely a great environment for experimentation and collaboration. And so, for instance, let's take a look at this thing called open processing, which is where we're going to be doing our work in the workshop today, or making our art. If we click on the Discover button, then it pulls up a page full of examples created by all the people who use open processing and P5, the JavaScript processing version. So I haven't looked at this in like a couple days, but there are some really cool looking things. So when you click on one of them, it pulls up first a view of the code. And if you want to just see the result of the art, you have to go up to the top and click this little button where you can see the play icon. And then the screen will change. And hopefully, if everything's working and there's no problems with their code, you'll start to see the results here. So I want to pause the video for just a minute or two, and I want people to go back to this Discover page, and I want you to look around and see things maybe that you are really interested by, and go ahead and click on them and watch the results. So go ahead and do that. All right, so I hope you found some interesting things that maybe really blew your mind. People who work on the sketches that you're seeing here, sketching meaning like you experiment for a little while, you make something. And people who work on these tend to spend either only a little bit of time or a lot of time. So sometimes they're very, very complicated. And so things that we're going to work on today might not approach the level of complexity that you see here, but just know that it's possible to make these really amazing works of art in the web using the tools that we're going to talk about today. So how can you get started making things? We are going to get all of us set up with an account, and it's not very difficult. In fact, you could probably do this whole workshop without having an account, just clicking on the Create a Sketch button. But the problem is you don't get to save your work, and you don't get to share it with other people. So it's important to start with an account. So the way that that would look is if I signed myself out, we go back to openprocessing.org, and you'll see this page that you probably saw when you first arrived, and go up into the top right corner and click on this little person icon, and go ahead and click on Join Open Processing. And it'll ask you for your name and your email, and you can put those things in, make up a password. I can't emphasize this little button enough. The click on Stay Signed In button can save you a lot of unnecessary frustration. I don't always like having to type out my information again each time I come in. And sometimes I make something really cool and it doesn't get saved if I'm not signed in. So fill that out, and I'll sort of meet you on the other side. I wonder if I'm going to edit out this part. Maybe not. It's kind of funny to watch me struggle with my own password. Maybe this is the hardest part. Oh my goodness, this is definitely the hardest part. Oh, yep, I'm typing it wrong. Okay. Ha! Wow. That was a doozy. Here we go. So, you'll probably have arrived on what is your profile page. And you have the option of editing your profile, putting in a photo, things like that. I haven't done that because I just want to make sketches. I just want to make the art. But that doesn't mean you shouldn't do it. So feel free if you want to. But the big thing that we're going to do is I want to just get us started making a sketch. So let's go here. And we click on Sketch and it opens up this page, and there's some stuff already here. And that's nice because it means we don't have to start from scratch. You can ignore the stuff on this right side. We might end up taking off this thing called loop protection because it can actually create problems for us if we're trying to do things that are a little bit more complicated. But go ahead and click these 3 dots and make that side thing go away. So this is already a sketch that is presented for us. So in a similar way to how we created or viewed other people's sketches, let's click on the play button up at the top. And you'll see the screen goes to a darker color. And now if we bring our mouse down into this area where the code used to be, we see that we can actually start to draw just by moving our mouse around. So all of these little circles get created wherever our mouse is going, and we can fill up the whole screen. You can do whatever you want. Make however, whatever shapes you want to draw with this. And then maybe you're gonna realize that this is just the tip of the iceberg, really. So if you want to go back to the other window, we can click this thing where it's got the angle brackets. I think that's what those are called, where they look like less than or greater than signs in mathematics. And there's a little / inside there. If you want to go back to the home page, that's what this button's for. And if you want to save your sketch, you click on this. And this button we'll go over a little bit later, but you want to use it a lot because sometimes things go away and you didn't save, and there goes your brilliant masterpiece. So save often. So let's go back to our code, and I'm going to talk about a little bit of what's in here and how it's creating the stuff that we saw. So briefly, how many of you have done the exercise where you're told to write out the instructions for making a peanut butter sandwich, and then another person gets those instructions and has to follow them exactly the way that you wrote them? if you've done that, you're probably familiar with the experience where the steps are not always exactly what they should be, and sometimes the person is left trying to get the peanut butter out of the jar while the jar is still closed. And so the whole exercise is meant to be an example of what's known as an algorithm, or a sequence of steps. So an algorithm is a fancy word for a recipe. And in the exercise I was talking about, a recipe for a peanut butter and jelly sandwich could be an algorithm. And what we're looking at here is actually similar to that. We have a couple of lines of text, and they are telling the program how to make a picture. Not a peanut butter and jelly sandwich, but a picture. And so let's briefly take apart these steps, and we can talk about what is going on here. So you'll see that there are these two things called setup and draw. And there are these are known as functions, like the word that comes before them. And what a function is, you can imagine it as a way to write steps all together, to sort of group them. And what's interesting is that anywhere that you see these parentheses coming after a word is another function. So they're written a little bit differently, but this is us using a function, and this is us creating a function. And sometimes you put stuff inside these functions because the steps that you've written in there that are grouped together might need the inputs that you provide. So notice that we don't actually give these functions setup and draw any inputs, but we write our code within there. And what that allows us to do is it tells the P5.js JavaScript how to set up our sketch and then how to draw it. And the difference between these two functions is setup only happens once. So let me go ahead and we use these two forward slashes to make a comment where this is not technically code that runs, but it helps us organize our thoughts and leave little messages for other people who read our code. So this only happens once, and it happens before this other thing called draw. And draw happens 60 times per second, if we're lucky. And the result of that is we get a picture that we see over here that seems very smooth and very reactive. Like it's not falling behind, and my mouse is not sort of escaping where all the circles are being drawn. They're all kind of happening in the same places at the same times, which is great. So the draw will continue to happen 60 times per second until you close this page by clicking on the code, or until you leave the open processing sketch that you're making. So that's a little bit about the functions setup and draw. But these things, create canvas and background, are also functions. And so you might notice that in our picture here, these circles are following the mouse. Well, we're actually making that possible with this line. So the shape that we're drawing is a circle, but it's actually an ellipse. An ellipse is a general version of a shape. And if we have an ellipse that is as wide as it is tall, then we call that a circle. And so these first two inputs are actually the center, the x-coordinate and the y-coordinate of the center of our ellipse. And then these are how wide and how tall in pixel values, which is the tiny little dots that make up our screen, how tall the ellipse should be and how wide it should be. And if these are the same, then we get a circle. So that's a lot of stuff, but it explains maybe how we are actually getting the shapes drawn where the mouse is. Go going back up, we need this line create canvas in order for our sketch to actually show up. We have to have a canvas before we can paint. You could think about it that way. And background is just setting our canvas to be a particular color all the way around. It fills the entire thing before we draw on it. So that's all great. This stuff was written in here before we got here, but can we mess with it? And the answer is yes. And the answer is you really should. So there's a couple of ways that we can change that. We can put in different values for our inputs here. For instance, this number 100 is actually a representation of color. And so if we were to put in a different color, like 1, then our entire picture would be covered with a different color. Now, when you don't understand things in code, it's really a good idea to just play around and type in something and see what happens. I think that that's the best way to learn. So I changed 100 to 1, and now we're going to rerun this thing. And we notice that now, instead of a sort of a light gray, we have almost a black as our background. So that means really low numbers are closer to black. So maybe if we go up to a higher number, we'll have a white background. Now we might notice also that might make the circles look a little different because they stand out on a black background because they're filled with the color white. But what number is associated with white? Well, it's a little bit of a strange choice, but it's 256. And if you want to stick around at the end of my talk, we could do a whole little explanation about why 256. And I'm just picking one value lower than that. So this will be a white background. There you go. So go ahead and play around a little bit with putting in different colors for your background. Okay, hoping everybody had some time to do that. The other thing that you might think about doing is you can actually sometimes give more than one input to things. So like in the ellipse, we have 4 inputs coming in. The mouse X, mouse Y, 20 and 20. The background right now only had 1. But when we think about colors, sometimes we can think about them in terms of adding a red value with a green value with a blue value to create a color that is the result of those 3. So if we give this thing, this background function, 3 different numbers, then we might be able to have something that's not just black or white or gray in between. Start to see that we can have maybe red, because red was the first input that we had here. So if we want to change to not have as much red, green is going to be the second one. And again, each of these inputs goes from 0 to that magic number 256. And the last one of this is our blue. So let's go ahead and go right up to the top of that, and we'll have a little bit of green mixed in. So we get this nice sort of, shoot, I don't know, this probably has a name. It's not blue, but it's like a mix. So there we go. So that's a couple of the things that we can experiment there. Another thing that we can try is, what if we don't want to have normal circles anymore? What if we want to have these sort of shapes that are like a circle, but aren't as wide as they are tall? So we can change these numbers to be different. And I'm going to say 5 and 20. But again, you might experiment doing something like a different pair of numbers. So go ahead and do that for a couple of minutes. Well, seconds, really. It doesn't take super long. You'll have the rest of your life to play around with this stuff too. All right. So that's great, but what if we want to make pictures that are more than just like a colored background with a thing that is either a circle or a shape that is like a squished circle? Well, there are lots and lots of other things that we can make use of in the P5JS library. They call it a library because it's kind of like a book is full of stuff other people have written, and P5 is kind of like a book and a library of code that other people have written. So that's sort of a failed metaphor. Let's move on. So we go to this link called the reference, and this is a big old page of functions that are already available for us. And you'll see that there's an entire section about shapes. So there are two other shapes that I want to talk about that are really great to work with. And they are the rect and the line. And so we're going to make a rect, which is short for rectangle, which is going to be a shape that has 4 lines that intersect to make a box or a space that is on the inside and the outside. So, and it, like ellipse, is also going to have 4 inputs. And if you want to understand more about what those inputs are, on this reference, we can click on rect and it'll show us a bunch of examples, which is really nice. I love pages that start with examples and then give you a description, because honestly, sometimes just seeing the line and what it makes as a result is enough to explain everything, instead of having to read through all this text. That's just me. I'm a visual guy. Guess I'm doing the right job. So what we start off with is the x coordinate for the top left corner. And then the y coordinate for the top left corner. And then we provide a width and then a height of our shape. So if we borrow some of what's already written for us and we use these things called mouse x and mouse y, which follow our mouse around on the screen, then we can do a similar thing to what we had before when we had our circle. Let's go ahead and make this 20 again. So now we're going to have not just one shape, but 2. So go ahead and type out those lines, and we're going to click on play. So you can kind of see I've got this little square inside of the circle, and they're both following the mouse around. And that's neat. So now we got 2 shapes in there. You might really not want to have 2. It's up to you. But there's another thing that's going on in here. Let's look at this. And maybe this whole like showing all the history of where your mouse has gone is kind of cool, but it's, you want to know how to maybe not have a sketch that fills up with stuff so quickly. So remember when I was saying that the background lays down color from one end of the screen to the other, it fills the entire thing? If we make that our first instruction in the draw function, which happens each time that the screen refreshes, 60 times per second if we're lucky, then it will effectively clear, or it will be drawn on top of all the old stuff, and we won't be able to see that stuff anymore. So we could just pick the same color for consistency. And as a result, the lines of our history are going to go away. It'll just be this one shape following our mouse around. I think that's a little nicer just because the shapes that we chose to put together are a little hard to see if we draw on top of them. So, of course, all of this work is dominated by your feelings and thoughts about the art, and those might be different for you, so you can make any of the choices you want. So that's the way that we can clear our sketch. And so that was our example using the rectangle. Why don't we now start adding a line? So I want to make a line that is centered on the mouse X and mouse Y coordinate, but sticks out past it. So it'll be like a line that cuts our circle in half. So the first values for line are the X and Y coordinate for the start of our line. So we're going to do mouse X minus some value. And the reason that we can get away with that is mouse X and mouse Y are just numbers in our code. So if our mouse is in the middle of the screen, it might be half the width and half the height of our entire sketch. So mouse X, mouse Y are just numbers. And if you don't trust me, you can go back to the reference and you can search for mouse, and there's a whole section about things that use the mouse, and it'll explain how the value changes over time and what you can do with it. So one thing that I should mention that's a little bit funky about graphics in general is they make 0, 0. Oh, my bad. I wasn't done typing some of this stuff. So let's put 2 forward slashes in front of that line and tell the program that it's not code and it shouldn't try to run that. But what I was saying is this corner up here in the top left, that is actually the coordinate X and Y equals 0, 0. Now normally when we're doing pictures in math and other things, we start down in the bottom left. This is where X equals 0, Y equals 0 would be. So that's going to be something that's a little bit different for all of the pictures that you make that need to use that Y coordinate. So remember, up is down. No, but really, 0 is at the top of your screen because that's how old-timey displays used to draw. So like old TVs used to draw from the top down, starting at the left side. Okay, let's finish what we were drawing in the line. So we were doing a little bit of math on whatever value mouse X is. And we're going to do a little bit of math on the value. Well, actually, we want to have our line be straight across. So we're not going to mess with our mouse Y value because then the point would be lower than our mouse. But we want to have the next point, or sorry, so the line goes between, line takes 4 inputs also. The first 2 are the X, Y for the start point on our screen. The second 2 are the X, Y for the ending point on our screen. So if we want to move over by a certain number of pixel values, and that certain number in my case is 5, we're going to add 5 to the mouse X, and then mouse Y is going to stay the same. Notice that if I had not capitalized this Y, we'd be in trouble. You can go ahead and give that a try yourself. It will show an error to you. That's because case matters, like whether it's capital or not, is important to our program. So let's go ahead and run this. And now you can see like this very, very tiny line that's coming off the little square that I have in there. Let's make that a bigger line. So instead of just 5, let's make that 50. There we go. Now it's really sticking out past that circle. All right, so that's a couple of the shapes that we can draw. I want to take a couple minutes for people to experiment with a few more of these shapes. Or go ahead and make shapes for yourselves, however you would like to in your sketch. They don't have to be put where our mouse is, but that makes things kind of interesting. So go ahead and experiment a little bit and tell me what you did when you get back. Okay, welcome back. So I think that we're going to move on to something that is a little bit different. So we talked about how these are numbers and we can do math such as subtraction or addition with other numbers. But there is another kind of thing that we can put into our program, which is like a little bit of text. And so fortunately, the background doesn't just accept one number or three numbers, it will also accept one, what we call string. And I don't know why this got chosen as the name for text in programs, but just got to take my word for it. It's called a string. And this will have the effect of making our background red. You can put in most other colors and it should work as well. So let's go ahead and run that. So you see that changing. And the cool thing is, we can also change the colors of our shapes. So let's look at the reference. The thing that we use for doing that is called fill, as in like we're filling the shape with color. And here's the example we're talking about. We're using a color string. Now, in order to color a shape, we need to have the use of the fill function happen before we draw the shape. So if we wanted to make our ellipse or our circle a different color than the background, we could go with green. Now if we want our rectangle to show up against the green background, we could make it white. Probably gonna make a flag using these colors, not entirely intentionally. And I'm gonna do a little experiment here where we're gonna type fill, but what's gonna surprise you is that this doesn't actually change the color of our line. And I will explain a little bit about that when we come back to this. So notice we have that green circle, our little square in the middle is white. That's nice. Now the reason we can't change the color of the line using fill is for shapes that have area inside. Our line is flat. There's nothing inside of it. So are we totally out of luck? No. We have to just use something else. We have to use a different function. Fortunately, the reference puts these things together. So you see here's fill, and here's this thing called stroke. Now stroke is used for the lines that are on the outsides of our shapes that have areas, but it also works on just lines themselves. So stroke, and then you can also put in a color, yellow. Actually, I love purple. So let's do that. So you can kind of tell. Purple is a lot like black, so maybe let's make that yellow so we can tell that it's a different color. There we go. Does anyone notice anything interesting happening? We also changed the outside of our circle, so that now is yellow as well. The reason that happens is this stroke sets the color for the lines on, well, our line, and also the lines on other shapes, because we're essentially starting at the top of the instructions in draw, going to the bottom, and then back up. Because it's getting called over and over and over. So you can think of this sort of as a cycle. So when we change the color for our line down here, it actually affects the line that's on the outside of our circle up there. So if we didn't want that to happen, we would need to set the stroke again up here. So just a quick fun fact, now only one of our lines is colored yellow. failed to mention that that line on the outside of the rectangle was also probably yellow. So. Great. So we talked a little bit about these things called strings. And now we're going to talk about this really big subject known as variables. And we're already using them in our program all over the place, but we should call them out. Now, variables are, in programming languages, a way to sort of hold something, hold a number or a string or anything really that you can express in your code, and then use it later. So it's kind of like how we have names. So my name is a way to refer to me as a person. A variable is a way to refer to something in your code. And what's really nifty is that a lot of these variables get created for us to use in our program without us having to lift a finger. So my favorites are width and height, which get made for us when the program starts. Well, that line up there actually makes them possible. So what's great is that we can do things like, let's have a line that goes from width back to our mouse, and yeah. So that's going to be all the way at the right side of the screen coming into our mouse. And let's do another one, which is mouse X. Well, okay, it'll probably make more sense if I write it this way. So we're going to have a line that starts at our mouse, where it's located, the X and the Y pixel on our screen. And then it's going to go off to the far right side of our screen, but we're going to keep it at the same height. So mouse Y for the start and mouse Y for the end needs to be the same. And it's going to be a yellow line because that stroke happened above, and it's still going to affect the second line. So now, it doesn't matter where we put our mouse on the screen, that line will connect all the way over to it, which is great. So variable is called variable for a couple of reasons, because we get to use the same term, width, regardless of the number that changed underneath, whether it is a variable quantity or not, if it doesn't stay the same or if it does stay the same. So sort of what variable means, it changes, there's variation. Anyways, I realize I haven't saved my sketch yet, so let's go ahead and do this. I'm going to name it something more inventive than my sketch. Women's Hackathon Intro to P5. And you're not done yet until you click the submit button. Let's go ahead and do that. And now, even if we were to reload this page, we wouldn't lose our progress. Okay, so that's one example of our variables. Now we can use the variables width and height all over the place. So if we wanted another line that was coming down from the top of our screen and going to where our mouse was, we could add a second one here, and we're going to start at our mouse X and our mouse Y, but we're going to keep the mouse X part, and we're just going to go up to 0. So that's going to be the top of our screen. And if we wanted another line, well, actually, let's change this. So my idea was to have the line go up to the top of the screen, but that's going to be kind of boring because we don't get to use the variable height. So this is going to be a line that goes from our mouse down to the bottom of the screen. Now remember, this is that tricky moment where height is actually measured from the top of the screen down. So bottom of the screen is actually higher values of the y coordinate that we're measuring. So this is pretty cool. Now, if you really want to see some funky stuff happening, we can put 2 little forward slashes in front of where we do our background. And what that'll do is we'll no longer clear our entire sketch every time that it redraws. So we will get sort of stuff adding up as we move the mouse around. So it's a fun little effect that you can see. So we start to get lots and lots of lines all over the place. And I think that when I first started learning this stuff, this was the coolest thing. So just wanted to mention it. So another of the functions that are really, really useful to just know about is this thing called random. And random is best appreciated if we give it the whole stage, meaning like, let's delete that code that we wrote already, and let's actually draw some circles randomly on the screen, just as the program goes, as our sketch runs. So remember, we can use the word ellipse. I noticed in the reference that we can actually use the word circle. So if you really want to, you can put your center of the circle for the x coordinate, center of the circle for the y coordinate, and then this is just the diameter. So don't have to specify 4 inputs, it's up to you. Just use that as an example. So the word random is a great word, means a lot of things. Well, and on the reference, if we click on random, it gives us some examples of how it gets used. You can do a lot of different things with it. So let's just experiment a little bit. So random is going to give us back a number in JavaScript. And this is going to be kind of, I love to experiment with the code. So people might want to take a guess about what's going to happen now. I'll pause, can say some guesses. And here we go. So the whole screen is kind of empty, but you can kind of see up here in the corner that there's a tiny little circle. But the reason that that was not really a random, or it wasn't showing up all over the screen, is the value we get back from random, if we leave it just as it's written on its own, gives back a number between 0 and 1. And fortunately, random is a special function, and we can give it inputs like the variables that are defined for our sketch when it first gets made. So now we're going to get a number is a number between 0 and width, and random height is 0 to height. So lucky us, it's like we get this cool kind of thing happening without really doing much more than writing one line. Of course, the extra special thing is that since we don't clear the canvas, it just sort of fills up with dots. So I think that that's kind of fun. Now, you can do all kinds of things here. So if you wanted to make the circles not show up randomly between 0 and width, you could make them show up within like 20 pixels of the mouse cursor. That might be a fun thing to try out. Or you could make them all show up randomly on a line that you just specify. Like one, maybe the x coordinate could be a random value and the y is just set to be a certain number. You can even use random here where the diameter is getting chosen. So this will maybe, let's pick numbers that go from, here's a good example of using another variation of the random. So random, if we give it one input, it goes from 0 to that input. But if we give it 2 inputs, number A and number B, then we get an output that is somewhere between those two numbers. B. So let's have a diameter that is getting created randomly, and it's somewhere between 7 and 30. So we're going to get some dots that are about the same size or some dots that are much bigger. So there's an interesting effect. Now you better believe it, we can use random for color as well. So fill, and we'll start off. Do you remember that the numbers for black and white go from 0 to 256? So we'll just do 255 here. Oh, that's not a 2. Great. So now we're going to get these circles that have different color on the inside. And you know what? My aesthetics are tingling. I think I just want this to be a black background. Yeah, for some reason that's more pleasing to me. It seems, I don't know, like the composition's better. Or just seems edgier. Like there's more grit. All these words that don't mean anything. Okay, anyways. So take your work as seriously or as not seriously as you like. So then here we go. We just introduced a couple of the variations of random. Random can also be given something that is like a list. Now in our everyday life, we have lists for like the grocery store where you have like get an apple and get a pear. I think when I first learned about lists, they were also using like vegetables and fruits and things like that in it. It's just a go-to. How do you spell Pomeranian? Is that it? Okay, I just needed to put something in there that wasn't a fruit or vegetable or edible item. So I'm gonna delete that. Anyways, so we can also use random on this thing called a list. And when we make a list, we have to use these square brackets. And for instance, if we want to actually choose between a couple of different colors, we could do this. So if we type out using strings, red, green, whoopsies, blue, then, oh, I'm not quite done. There's nothing random going on yet. So we have to make this thing between the square brackets inside of our word random. Now this might look a little crazy because the input to fill is using a different function which has its own input. This is totally legal, it's just a little bit weird to look at. So we're gonna go ahead and click on this, and we should start to see random sort of choosing one of those options for us as it makes these shapes. So that's a bunch of the ways that we can use random. I want to stop for a minute and let you experiment a little bit. Because random is great. I feel like the lid got blown off of the cool things that I could make as soon as I learned about random. So go ahead and experiment for a little while. So we've just taken some time to look at the wonderful tool that comes with random as a function and all the ways that it can work. And we also got exposed to this new thing called a list, where we use these square braces around things that we separate with commas. So we haven't really learned how to make our own variables, though. We've been using other ones like width and height that we just get. And the way that JavaScript allows us to do that, there's a couple of different ones, but we're just going to look at this thing called let. And let needs to be followed by the name for your variable. And I'm going to talk about how we create variables and how we write text at about the same time. So I'm going to make a variable and I'm going to call it my, and I'm going to use an uppercase here, big statement. And then you need to use the equal sign because we are going to be connecting this name for something to a number or a string or whatever it is that we're going to try to make a statement about. So that ultimately we really enjoy looking at pictures of cats for some reason. My friend has just been sending me a bunch of cat memes. Maybe we can each share our cat meme favorites at some point. But you notice that I'm doing the same thing where I'm putting in quotations all of this text. Oop, that's going to cause a problem. And so this is a string, but we have spaces inside of it. That's totally fine still. In fact, in JavaScript, we could even use just a single quotation mark, but you have to have the same thing on both ends. So that works, or what I had written previously, but you can't have like one full quotation and one sort of apostrophe. That also, yeah, you gotta have the same thing on both sides of the text. So speaking of text, P5 gives us this thing called text. And of course, I'm going to find a couple of examples of the word text in context of the word context. So here we go. But this is how we use it. So much like we use stroke or fill to change properties of the shapes that we drew, like color was the property that we were changing, we can use text size to change the size of text that we draw on the screen. And it's a function that takes 3 inputs. And the first input needs to be a string of some text that you're going to put on the screen. And then the next 2 are the x and y coordinates of where you're going to write that text in the screen. It's pretty nifty. You can do a lot of other things like providing more inputs and creating text that wraps around instead of just staying on one line. I didn't even know that. That's really cool. So let's just try putting my statement on a single line, and then let's play with putting it on or wrapping it around after. But you notice that they were writing for the first input something in quotations. Well, we can get away with just putting in this other thing, which is the name of my variable. So my big statement can go here. And essentially, it's like we are swapping this out with all of our text here. That's how variables work. We call it, it's like it's making a reference to this thing here. And that reference is the name. So the other variables or the other inputs that we need are the x and the y that we're going to do this. And we just talked about random, so why don't we use it again? So we're going to have this text show up at random spots in the screen. And I think the background is still black, and so we might need to change it so that we can actually see our text. So red is kind of an intense background, so let me change it to some color that is sort of up towards the lighter end of the spectrum. So we'll do a little bit of red, some more green, and then also some blue. So we're going to get sort of a compound color. Oh, and I need to, you notice that sometimes we have parentheses, and if I had left this off, let's go ahead and troubleshoot what the result of that is. It's going to say, uh-oh, we got a problem. Syntax error, missing parenthesis after argument list. So input and argument mean the same thing. So these are my inputs. They are also my arguments. I know that might be a weird word because argument normally means you're mad at somebody or you're talking about something. But I guess there's probably a definition of the word argument that fits this context. But I like the word inputs more. just know that we need to put that second parenthesis in there. Oh my goodness, everything is going everywhere because I forgot we are clearing our previous contents away. So it's just jumping all over the place like crazy. So this is a great moment to say, let's remind ourselves what the difference between putting the background in our draw function is compared with putting it in the setup. So the setup, again, things only happen once. And if I want to have sort of the screen filling up with the result of all of these random statements being placed around and these circles going everywhere, I probably don't want to continue to clear the background. I just want it to happen once at the beginning so that we have that nice background color. So here we go. Whoa, oh my gosh. Everything is filling up the screen. What's going on? Oh my gosh. My statement is taking over. Okay. Thanks for going through that with me. Now, that's the way that we make text. It's also the way that we make variables. So we're going to move on to something a little bit different. And it's going to be a bit of a switch from what we were just doing. So I'm going to delete this stuff again. And we're going to talk about how you can write code that happens only if something else happens. So you can set the conditions for whether code happens. And if those conditions aren't satisfied, it doesn't happen. And if they are, then you're in luck. And we call that a conditional. And usually the word if gets used across all different programming languages. This is pretty common. But you have to write if, and then this is a little bit weird. You have to make some parentheses. And then you got to use these weird curly braces. So what's happening here is this is where we're going to lay out our condition. And in between these two curly braces is where we're going to put the code that needs to happen if this conditional works. So the example that I like to do is let's go back to using some fun interactive things like mouse, and let's use another variable that's given to us like width. So what this means is we are going to check the value of our mouse, its x coordinate, and we're going to see if it is smaller than the halfway point of our width. So halfway across the screen in the x direction, left to right. And if that's true, we're going to do something like change the background color from, let's get some random numbers. Yeah, speaking of random numbers, let's use random, well no, we should have a result that we know is one thing. So green. So if the mouse is on the left side of the halfway point of our screen, we will get a green background. And the way that we specify the case where our code gets executed if this isn't true is we use the word else. So we always have these pairs of things, if and else. Well, we don't always have to have an else, but if you want something else to happen, you have to type that. So you use another pair of curly braces, and this is where we're going to put our other piece of code. So if that's not true, we want blue. This is pretty standard. Oh, I haven't saved in a while. Let's save again. Okay, so we are on the left side of our screen. Background is green. Moving over. Now we got to switch. And we moved over again. So it's kind of hard to tell that that's the line that's dividing things, but fortunately we can make ourselves a line. So let's go from width equals half of our width. That's the top of our screen. I know it's still weird, but now we are going to go all the way down to the bottom. So this line is purely vertical because the start x and the end x are the same values. So let's make this a yellow line. Wait, I can't just do that. So stroke, again, determines the color of lines. So let's do that. So now we have this dividing line that we can see when we cross it, stuff happens. It's important to give yourself these little aids. So that's what we call a conditional. And this is a tool for controlling the flow of our code. It's a fancy, fancy thing to think about. Like, we're flowing along, going top to bottom each time that this function gets called, 60 times per second. So, pretty cool. But that's not the only kind of flow control that we can do, which is kind of a wacky idea. We can also, let's say, if we had, so bear with me for a second, here we go. If we had a thing like an instruction of how to draw something and we wanted to repeat it a bunch of times, it might be kind of tedious to write one line for each of those things. So if we wanted to do like a series of rectangles that move from one side of the screen to the other, or maybe just 4 of them, because I don't want to type that many lines. So if we start from a value like the 20th pixel in the X, and we'll go halfway down in the screen, height divided by 2, and let's make this 5 by 5. Well, those are hard to see, so 10 by 10. No, those are still hard to see. 20 by 20. All right, so rectangle. Now, if we wanted to make, that's one, if we wanted to make 3 other ones, we could be really clever and copy and paste this and then change this X coordinate to like, let's make this 50, and let's make this 80, and then 110. So cool. I guess that's going to be one thing. So here's our little squares. But if we wanted more than 4, like we'd start getting a lot of these lines that we're just adding up. Unfortunately, we have another control or another flow control technique called loop, which means that you can repeat commands without having to type them all out. So like there's 2 variations, or the while loop. And so 4 is a pretty good one to start with. So the way that it looks is we're going to do a similar thing where when we had the if, we wrote if, 2 parentheses, then a curly brace, and then another curly brace. And when we had the if, the section in between the curly braces was the code that needed to happen if the conditional was correct, like if mouse X was actually less than the halfway point. But the for loop is going to be similar, but it's going to be the section where the code gets repeated is what's inside these curly braces. So, well, I don't really want to delete all of those. I want to delete 3 of them and copy 1. We're going to start our instructions for the for loop. So what happens inside these parentheses? So when we made a variable, you might remember that variables start with the word let, then we give a name for our variable, and then we use an equal sign, and then some number or something. Just gonna write JavaScript thing. Okay, cool. So let, and there's sort of a standard practice of giving the variable that you put in here just like a 1-letter name. People use I a lot. And I'm going to start our I as equal to 0. And then I use a semicolon because the thing that comes after that is going to be a conditional like we wrote up here. So something that is, there's a condition that is satisfied when the variable is less than another variable. So I'm going to use I again. I'm going to say when I is less than the number 4, because we want 4 of these little squares, then we are going to loop. And this final thing is when we change the value of I. So I'm going to say I equals I plus 1. Now this is a bit funky. I have I on both sides of this equal sign. But bear with me. If you imagine that we start off at 0, then this is 0 plus 1. And then we set that, which is the result is 1, we set that to be equal to I as the new value. So I went from being 0 to being 1. And we do that whole thing 4 times. So I, when we loop the very first time, so in our loops, first time equals 0. The second time I equals 1. Then I equals 2. Then I equals 3. And then the last time we stop when we reach the point where we compare I to the number 4. So if I happen to be 4, then we would have 4, which is not, according to math, less than 4. So since this thing is not true, we'll stop our loop. I didn't explain that there's an entire class of JavaScript things, like there are numbers and strings, called Boolean. And Boolean can either be a true or a false. And when we have this whole thing like I is less than 4, it will become something that's either true or false. So that's what conditionals are really, what they boil down to at the end of the day. The end of the day, when they're executed, or when the code that I've highlighted runs, it will become either a true or a false. So right now, though, this is going to be 4 rectangles that sit on top of each other. But what's pretty nifty is we can actually use the variable that we made, I, here inside the loop, which is super cool. So so we can actually use it. We could do 20 plus I, but that's not going to be squares that are in that much of a different place. Or we could do another piece of math. We could multiply 20 by I. And so the first time when I is 0, our x value is going to be 20 times 0, which is 0. The first time it's going to be, or when I equals 1, we're going to get 20 times 1, which is 1. And then it's going to continue to move its position in the x-axis along by 20 pixels each time. So go ahead and do that. And look, we got this sort of solid thing. Unfortunately, I kind of want us to be able to see the gaps between our squares a little bit. So I'm going to change our width to be less than the amount that we're moving over in the x-axis. So there we get some gaps. So let's take a break. I want you to play around with some of the parts of this. So experiment with putting in a different number here, experiment with putting in a different number here, and experiment with putting in a different number here. And of course, you can play around with the contents of your for loop as well. So I'm going to pause. Okay, so if you're like me, you just went straight for it and you made that number no longer 4 and you multiplied it by like 100 or something. So now we have boxes clear across the screen, which is super great. And we're still getting this like dynamic of moving the mouse from one side to the other. So that's quite a bit of stuff. We could actually start to combine all the different things that we've learned. So you could be putting in boxes that are at a random height, that have that particular set of x and y values for, or sorry, width and height values for the box. We could also be changing inside of this loop the color that we put inside of it to be something that is between a few different options, like maybe green. Yellow is kind of hard to look at, so let's do purple. It's my favorite color, but I really struggle at spelling it. Do they have cyan? Is that gonna work? Anyways, let's try that. So the idea is now we're gonna have boxes that show up at different positions in the y value and are filled with different colors. So here we go. Oh yeah, and it's happening 60 times per second, so they're all over the place. If you, like me, are sometimes overwhelmed by that, you can actually change the speed that these things happen by typing out the word frame rate with the R for rate capitalized, and then you put a number in, something like maybe 2. And this is going to slow everything down. So frame rate is going to drop from 60, which is the default, to 2 frames per second. So this is going to look really chunky, but sometimes it's nice. You can go slow, you can sort of understand what's happening. You're no longer freaked out by the results. Oh yeah, and cyan works. That's good to know. Oh yeah, and the background changes when I move the mouse. So, so that's a bunch of cool stuff so far. I'm gonna say we will try a few more different things, but that is the bulk of what I wanted to show you. So feel free to use all the variations of the things that we talked about, and share any of the results that you have with me or anyone else that you think might like them. So